basics of probability theory, and in that I covered some basic definitions followed by probability, the classical definition of probability. As I earlier discussed, probability definition can be classified into three categories or classification. First is classical definition of probability, second one is probability introduced through axioms, and third one is probability through relative frequency. So in this video, you'll come across topic called probability introduced through axioms. See, axiom is a rule or a statement. So first of all, we'll see what actually an axiom is. So axiom is a rule or a statement that is accepted as true without proof. So there is no proof for this, but we accept it as a true. And the other name for axiom is postulate. So we'll see what are those postulates or axioms which define the probability. So there are three axioms which define the probability: axiom 1, 2, and 3. So let us go into this axioms. So axiom 1. So first axiom is P of A is always a non-negative number. That is, all of us know that the range of probability is in between 0 and 1, and always the probability of an event A, if I take an event A, the probability of that event will be always greater than or equal to 0. That is axiom 1, which means that probability of event is always a non-negative number. Hope you got clear, and I hope that you understood. First axiom is always probability of an event is always a non-negative number. Coming to the second axiom is, we know sum of all the probabilities or probability of sample space consisting of all the possible outcomes is always unity or 1, or I can say summation of probabilities of an event is always equal to 1. Second axiom. Coming to the third axiom. So third axiom is very important, which is we are going to make use this axiom for doing the proof of total probability theorem and Bayes theorem. Third axiom is probability of union of n elements or events, not so probability of n events. For example, n is equal to union of n is equal to 1 to capital N, or probability of events I am assuming to be A1, A2, so on here, then the union of all these events is equal to sum of individual probabilities of those events. So I'll repeat once again. The probability of union of n events is equal to sum of individual probabilities of n events. So this is very important point or important axiom which will make use in the proof of total probability theorem and Bayes theorem. Coming to the next topic, mathematical model of experiments. So the mathematical model can be derived using following three steps. So we can derive a mathematical model in three steps. See, you don't see this slide. I'll tell you what actually mathematical model of experiments is. See, whenever we are going to solve a problem in probability, so what is the first thing we'll do? We'll define sample space. Second thing is we'll write down the favorable outcomes. Third thing is we'll we'll go for solution of that problem with the help of wherever we require any axioms, and that axioms that too have to be satisfied. The resultant should be satisfied with the axioms of probability. So these are the three common steps. So that is nothing but mathematical model of experiments. So mathematical model of experiment is nothing but first of all we have to define a sample space which represents possible outcomes. Second step is we define the events to mathematically represent characteristics of favorable outcomes. That is nothing but we are going to note down the favorable outcomes. And third one is whatever the solution we get, so that solution we have to check whether they are going to be satisfied with the axioms of probability. So this is about mathematical model of experiments, right? And third type of probability which we are going to define is relative frequency. With the help of relative frequency, probability can be defined. So here, definition of probability through relative frequencies: if I am going to perform a random experiment which is repeated n number of times, so there is a experiment which is going to repeat n number of times. Within that repetition, if I consider an event a occurs n of a times, that event is going to occur within this n times, it is going to occur n of a times, and the probability of event a is defined as relative frequency of a, the number of trials n tends to infinity. So I'll give you an example. When we are going to flip a coin, so I'm going to flip a coin n number of times. So the event that the coin shows head is, for example, A, and showing the head is I'm going to occur n number of times. And this small n of A, that is showing head on the coin, if this random experiment I'm going to perform for n number of times, which is going to be infinity, 1, 2, 3, so on up to infinity, and this event occurring n of A is called relative frequency. Simple words, relative occurrence of this event for n number of times. So this is called probability as relative frequency. So once again, we'll revise the concept probability definition. Probability can be defined through classical definition. Second one is through axioms, and third one is through relative frequency. Right. Next. So next topic is very important topic: joint probability and conditional probability. These two topics will, after completion of this theory part, we'll see the problems on this joint probability and conditional probability. So first we'll look after this joint probability. You all have studied this in your school days or even in intermediate or first year BTech also. So just we'll revise what is a joint probability. If we consider two events A and B which are not mutually exclusive. So first we need to know what actually are not mutually exclusive. So what is a mutually exclusive events? So if this if A and B which are not mutually exclusive, then the probability of these events occurring jointly or simultaneously is called joint probability. So I'm considering two events A and B which are not mutually exclusive. And the probability of the joint probability P of A intersection B is equal to P of A plus P of B minus P of A union B. Right? Or if I want to find P of A union B, simply you take this to the right side, P of A intersection B, then you get P of A union B is equal to P of A plus P of B minus P of A intersection B. And this condition is P of A intersection B must not be equal to 0. And they should not be, there should be a common relation between A and B. And always P of A union B will be less than equal to P of A plus P of B. This point is very important. Right? Next, conditional probability. The conditional probability P of C, most of the students read this as P of A by B, but we have to read it as probability of event A given event B. You have to tell, you have to read it as P of A given B is the probability of event A occurring on the condition that the probability of B event B is already known. So its definition is mathematical expression is P of A given B is equal to P of A intersection B divided by P of B. The condition is P of B must not be equal to 0. Why? Because if P of B becomes 0, then the probability becomes infinity, which does not satisfy the axioms of probability. Right? Similarly, P of B given A is P of B intersection A by P of A, and similarly P of A should not be equal to 0. The simple way to remember is whatever the event we get at the denominator side, so that will be, you have to write as in the mathematical expression as probability of that event at the denominator side. So this is about the basic concepts of probability theory. and in the